Okay, and we're back. So we talked about the wrap.py program in length, in depth, if you will, over the last movie. Now we're doing this one. So really what we wanted to kind of demonstrate here with wrap.py was how this ball class really works, right? So we've kind of done that in great detail, so I'm not going to do that again. And again, we talked about these two parameters that it takes. I'm kind of going to skip through this, the presentation itself, because I went over the details of the code within Aptana Studio. Okay? So I'm going to skip down to, this is the wrap area, where it actually does the wrapping of the screen. So it uses this code. And we've kind of talked about how it does one or the other. Okay, so let's talk about the bouncing ball. So now we're going to look at bounce.py. Okay? So kind of the same idea, except we're going to do a bounce. Now bounce is a little bit different. So let's take a look at what a bounce is compared to a wrap. Remember, it's supposed to, when it gets to the boundary, our code is going to make it do something different. Let's take a look. Okay, so let's just run the code. So here's the same ball, right? And now it's bouncing back, as you'd expect, right? So here it goes on the screen, boom, boom, and it bounces. Now this is kind of neat because you're almost creating this pseudo-physics here, right? You're making it look like there's a physics to the ball moving and bouncing, right? It's bouncing back in the direction that it came from. Okay, there's some complications here that we're going to talk about, right? I mean, this could be almost like a precursor. If you don't look at the actual trail, the line that is drawing, it could almost be a precursor to some kind of a Pong game, right? I mean, you got a bouncing ball, and now it's going to bounce off another sprite that you're going to create. You can totally do that. And this is where Pong came from, right? When it hits the back end, it doesn't bounce, it doesn't wrap, it disappears, and the person loses a point, right? Pong. Two players, one on one side, one on the other side. But in this particular case, it's just the ball bouncing. Let's see how it works. So if we look at the code now, it's exactly the same ball sprite, right? Same stuff. dx and dy value is the exact same as the original sprite. The old center, it draws a line, all that stuff. But the bounds function, this check bounds function, was where all the funky stuff happens. How does it work? Well, it uses a multiplication incrementer as opposed to incrementing with a plus or minus value, right? So it's saying when the right side, and here's a little bit different here, when the right side of my rectangle, the right side of my sprite is greater than the screen width, right? Then what I want to do is I want to bounce it back. I want to change my delta x. I want to multiply it. I'm going to actually increase the speed to minus 1.1. So I'm actually going to reflect the direction that I'm going in from a delta x perspective. And I'm actually going to increase the speed by 10%. So it looks like the thing is picking up speed. Okay? Now when the left side of my sprite hits the left side of the screen, right? It's actually going to decrease in speed because I'm actually going to take away 10%. Okay, so I'm going only 90% of the speed, so I'm actually reducing the speed. Okay, and the same thing for the bottom. If the bottom of my sprite hits the top of my screen, I'm going to reflect it as an example, whatever it is. I'm going to reflect it by remember because a minus times a minus is a plus, so I'm going to reflect the direction when I go to the bottom, make it go back up as an example, and I'm going to slow it down. And when my top, right, is less than or equal to 0, which when it hits the top, it's going to reflect it again using a negative value and increase the speed. So if you notice, the ball actually gets faster when it hits the right side of the screen and the top of my screen and slows down when it goes to the bottom of the screen or the left of the screen to create that physics-like effect. Let's take a look. Right? It's almost like the bouncing kind of effect. So here it goes, so boom, right? And then now it's speeding up again, and slowing down. And slowing down. Now it's very imperceptible, but let's suppose we fool with these values, right? And we use minus 1.1 for all these values, right? So I said, I'm going to continue speeding it up. Every time it hits a corner, I'm going to continue speeding the ball up, to infinity. Let's see how it goes. How long it takes for it to just speed up. So boom, it speeds up, speeds up, it speeds up, it speeds up. It's going to keep speeding up. Now, here it goes. It's going to get pretty quick at some point. Here it goes. And it's also going to change the direction of its path, right? So here we go. It won't take long, right? Here is where it goes crazy. Now it's creating a ball that's really speeding up infinitum to the point where you can't see it anymore. And it's going to crash the program. So, again, what I recommend to you, and if you notice, look, it did crash. It says invalid rect assignment because it got to the point where it was way too big. And that's why it kind of it reduces it here and here. If I go back to its values, it tries to compensate for some of the the gain in speed, right? If I was to change this to, instead of 1.1, if I was going to go a little bit faster, so I'm slowing it down, but not enough. So let's say I go 1.2 only on the right-hand side. So every time it hits the right-hand side, it's going to really speed up a little bit more than normal by 20% instead of 10%. Again, you're going to see some really weird things going on. So here, boom, it speeds up a little faster. It speeds up again, and then it slows down only 0.9. Slows down 0.9, but when it hits the right side, boom, it speeds up again really, really fast. And again, it's going to create a different pattern. If you notice, the pattern is always different according to the speed, right? Because it changes the dx value a lot more drastically, so it creates a different pattern, right? Again, if you're going to notice, if you leave this long enough, it'll speed up to the point where it's too fast, right? And you're going to see some dotted lines. Because 0.9 is slow, and then it gets to this point here. See what happened? Take a look, guys. I know, you're looking at other things. But see how it's doing this up and down? It's created an anomaly where now the y value is created almost like a zero effect. And 0 times 0 is still 0. Right? That's why it's doing this. So how did it get there? It got there because we have an anomalous value here that I've added in, 1.2 instead of 1.1. It's not congruous, and what happens is it's going to get to the point where it speeds up. If I really make this really crazy to make it happen faster, I can increase this to 1.5 from a bounce perspective. So 50% increase in speed when it hits the right side only. Okay, so it goes down, hits the right side. Now it's going 10 instead of 5, and now you see it happens really, really fast. It's trying to figure out that 0.9%, and it can't figure it out. It's going to zero out, right? And it kind of creates an anomaly. It's the percentages that they get muffed up. Okay, because it can't reflect something that it doesn't understand. So it can happen really quickly. The only way it can happen better is if I add some kind of, times equals minus 0.5 and plus 5, or minus 5 or minus 2 or something, to change the value so it's not exactly 0 all the time, right? So you can fool around with these formulae or these calculations, if you will, and to the point where you can modify the bounce. But really the bounce is it's checking to see the right side of the screen, then it's reflecting it with this minus 1.1. Otherwise, the rest of the program is exactly the same. The code is like the other one. Okay, and I'm not going to create new balls here. We've already done that exercise. But you can, if you wanted to, you can modify your constructor here so that there's more objects that you can reflect. Okay? And it'll create a different reflecting pattern. So again, we talked about this a little bit. So again, this is neat what it says here I'm going to read some of this. Check for the edge of the ball hitting the screen rather than the center. So you're not checking the center of the ball because that means the center is part of the ball is going to be outside of the screen. The bounce has to check the right or the left or the top or the bottom of the ball, the sprite that's bouncing. Multiply dx by minus 1 to bounce off a vertical wall or a horizontal wall, right? Use a smaller number to stimulate the loss of energy that happens in a real collision. For example, multiply by 0.9, minus 0.9, right? So you can actually lose energy, right? Now, if I was to do that as an example, going back to that example, oops, there it is. So I start off at 5 and 5, right? And this time, instead of gaining energy, I change this to losing energy. Eventually, it would stop. It would stop moving. The ball would kind of come to a stop, which is more accurate in some ways if you had some kind of physics. Right, here it is. Okay. The other thing is, if you really wanted to modify this more, when I'm reflecting from the bottom, instead of having a 0.9 loss, right? Because I want the right and left side will have a bit of a loss, but I'm reflecting from the bottom. I really want to have a much more loss, like for example, 50% of the loss, because almost like to simulate gravity, right? I could actually do something like this. So, no, actually it's the other way around. It's this one. Okay, so now when you look at the ball, I'm losing energy from here, all right? And as I go, I'm going to continue to lose energy, right? Here I'm losing momentum, so it's going slower and slower. And when I hit the bottom again, it's going to be halved, right? Now this is the trick. I only started with a dx value and a dy value of 5. So it's going to get to the point where, it's going to kind of really slow down a lot when it comes down to the bottom, right? So this doesn't really reflect kind of correct physics, because what you want to do is when it's reflecting down, you want to increase the speed, right? And when it's reflecting back up, you want to decrease the speed, right? So let's try that. So again, when it hits the top of my screen, here we go here, I want to kind of say, I want to increase the speed from my top, right, to 1.1. So I want to really kind of increase the speed, or 1.2, let's say. Right? I want to slow it down when I get to the bottom, and I'm going to slow it down when I get to the sides as well, but not much. Now let's try that. So boom, boom, hits the bottom, it slows down by half, hits the sides, right? Slows down half, and then it really kind of speeds up again as it goes towards the bottom, right? And then it slows down again. Now again, this isn't true physics because I don't have a bottom. What it should be doing is, if it's true physics, it should go in an arc, right? Not straight lines. But you can do whatever you like with the reflection, the bouncing, right? It's all around how you program what your effect is going to be, or what you want it to be. Okay, there's the plane again. So let's take a look at stop.pi to look at stopping boundary. All right. So again, when the sprite stops when encountering any wall, and you set dx and dy value to 0 to stop the sprite's motion. Okay. And it says may also incur damage in a real game. So if you hit a wall, somehow you create that boundary where you slide on a wall and create some damage. As an example, especially if you're playing a car game, some kind of you have car and you have two walls on one side of the screen and another side of the screen, and then your car collides, your avatar collides with the walls, takes damage. That makes sense. So let's take a look and see how that works. So we'll go and do the stop. Okay. See what it does? Boom. Hits the wall and stops. Right? And if you notice, this time it accelerated until it hit the wall. Right? And it doesn't go anymore. That's a boundary checking stop. Let's try it again. Boom. It accelerates until it hits the wall. Now this makes sense if it was going to go down too. And if you notice our dx and dy value, my dy value is 0. Right? So I'm actually not moving in a positive x and y direction. And my dx value is 2. If I was to reverse these and say my dx value is 0 and my dy value is 2, it's going to go down, right? The direction of the sprite is going to move in a different direction. Right? And it's going to stop at the boundary. Okay? So let's try that again, just to see that in play. To make it accelerate more, it didn't accelerate much there because it started only at 120 and 240, so that's the x and y, and 240 is quite low. So if I want to really try it more, so I'm going to go at 320, and I want to change my my other value to let's say 10, right? So it's not so high; it's much higher up than it would normally be. So in the middle of my screen, up here. Now, if you notice, because I'm off the screen, my boundary checking is working where I'm not going to fall, because my boundary checking is saying, "Hey, I'm off the screen, so stop me," right? So it's got to be more than 10. It's got to be something like the size of the actual sprite surface itself. So it's got to be like 40, right? It's got to be outside of that surface. Let's try it again. So here it is. Boom, it falls. And it accelerates all the way down, just like a normal ball would to some degree. It's not exactly 9.8 meters per second squared, just like it is in physics, but it's very similar type of fall that we're trying to do here. So how does this work? So again, we have a center x and center y position, a dx and dy value. The update's exactly the same. There's no difference here. It's this. Our check bounds is a little bit more complicated than it was before. So what am I saying here? I said if the right side is greater than my width, right, then the center x is equal to the width minus 15. It actually sets it there, and then it stops my motion. It sets my motion, my dx and dy value to 0. Okay? However, right, if neither of my values, if I have any kind of positive direction, this is what this is, and this is weird for a check bounds function, then I want to keep on increasing my x and y values to infinity. Okay? To infinity. So I'm actually going to continue to multiply it forever. If I want to simulate a diagonal, I can put in 1 or in 1 and 1, let's say, and then now it's going to go in a diagonal fashion. And if I want to move it at the top left corner of my screen, I'm obviously going to have it, let's say 40 and 40. So that's the top left corner of my screen. And when I do that, it's going to stop at the top left corner, and boom, it's going to kind of go down forever. Now, why does it go down forever instead of stop here and show me? Because I'm not doing the proper check. Right? I'm saying if rect bottom is greater than the screen height, then I'm just stopping the motion. Right? I'm not resetting it. I'm not doing what I'm doing here. Right? Where I say self-rect center is equal to the screen width. I got to do the same thing to the screen height. So if I want to make that work, that little effect I just made, I've got to add this other line. I got to say self.rect.center x, right, is equal to self.screen, right, dot get height. So I'm going to kind of put it at the bottom. I'm setting it to the bottom. I'm kind of shifting it back up really, really quickly, right? So let's see how that works again. So I'm starting at the top left, moving down, and then boom, it crashes my code. I like it. Let's see what it said. It says, ball object has no attribute screen, right? Yeah, I put screen instead of screen. That was and it accepted it. This is a great opportunity for us programmers to see a traceback. Boom, it's crashed again. Why? It says, Pygame rep object has no attribute center x. I spelled that wrong too, right? So center x. Let's try that one more time. Some good tracebacks we're getting. Boom. Didn't stop again. Well, come. What am I doing wrong, guys? So I'm saying my center x is equal to this, but I'm not subtracting, right? Otherwise, it's off the screen, right? So I got to do one of these. Let's try that. Try it again. Boom. Still not working. I don't understand. I'm trying to copy the same thing. Anyone have an idea? Screen height, right? My center is the screen height. That's what I've said it does, right? I'm keep moving. I'm checking if the bottom of my sprite, right, is greater than or equal to the screen height, right? Then what am I doing? I'm saying, well, set it back, right? It did exactly the same thing. Well, guess what? It's not the x I care about, right? It's my center y, and that's why it's not doing what it's supposed to do, right? Let's try that. Boom. Oh, that was a weird bounce. Not only did it bounce, but it kind of moved over, right? So you see the complications, right? I need to do both things. I need to put center X and center Y and shift it back. So it not only it didn't stop it, it actually shifted it. Let's see that again. Right? Boom. Right? Minus 15. If I set another value like minus 30 in here, right, and try it again, it's going to be even more dramatic. Let's see that again. Boom. It bounced. Right? If I keep it to 0, so like this, boom. It's going to be half inside the screen. That's bad. And if you notice what it did was, it kind of left the screen at an odd angle, right, and then came up. So it's already back down here, right? It's down off the screen, down here, and then it comes up, right? And why is it happening here? Because what am I checking? My bottom. I'm checking the bottom. If the bottom is greater than or equal to the get height, right? So it's greater than or equal to. Why? Because it keeps on accelerating so quickly that there's going to be a chance where the next time I check my my update, right, as I'm accelerating towards the bottom, right, the next time I'm listening, it's too late. It's already off the screen, right? Now, if I was going to, this would work fine, right, minus 15, if I was only going in a linear fashion. If I was only going to go down, right, instead of a diagonal. If I move down, boom, it's going to be okay, right? It's still going to be weird, right? Because you notice it's going to shudder a little bit. Watch, right? Kind of shudders, right? It goes boom, boom, right? And the reason why it does that is because it's probably moved off the screen, right? So if I don't make this check and I just stop it, how do I do it? Anyone have any idea of how do I stop it? And as I move towards the screen, right, without passing the screen and sending myself back. Anyone have an idea of what you can do from a coding perspective? Come on, sleepy class. Not really cool though. It's not bouncing. We want it just to stop. We want a hard stop when it gets to the screen. We don't want it to go off the screen and stop. We want it to go. Yeah, but in this particular case, we're doing a stop for a thing. Yeah. What about the projected next position? Right? You know the position, right? You know, because your calculation is going to be whatever. So if you say this, if I project where my object is going to be before it gets there, right? I know that it's going to pass outside of the screen, right? What I want to do is say, on the next check, make it equal to the screen. Don't increase my speed anymore, just stop it. Stop it at the screen, wherever it is. Boom, and it stops right at the screen. So that's another way you could do it. Some tricky stuff, and it might not look right, right? Because depending on how you do it, it might look like it's kind of decelerates to 0, right, for the next screen. You don't want that to happen either. So you can play around with the code, is what I'm saying, to come up with a nifty little effect when it comes to checking Brownie check. Now, if you're moving a slow object, this wouldn't be the case. You wouldn't have this problem as much when you're moving a slower object. Like, for example, if you're scrolling your avatar, it may not be an issue anymore because your avatar would scroll so slow that on update, you wouldn't have a problem, right? That's the whole idea with it. The only time it's causing an issue, right, is when the avatar is moving too fast, like this. See, this actually bounced back. You can't see it, but if you watch it closely, let's take a look at this, the original. Watch it closely. See, actually kind of, now it's faster than the eye can see, but actually kind of reflected back really quickly, right? And it's kind of an ugly effect. If you think about it, it's a really cheesy effect, and that's why it doesn't work on a diagonal, because what it's doing is this setback where it sets the boundary back to the original number again, if you're kind of setting it to the right side, it's moving in such a speed that it doesn't allow the update to happen fast enough, right? Where the update can't catch it. Before you're able to stop it, it's already off the screen when you're doing your check. Okay. So that's one of the trouble, one of the issues you're going to have, as an example, when you're checking for boundaries when it comes off the screen. Okay. So talked about this. Let's talk about it can have more than one image. I like this. So here's we're actually getting into animation. This is the kind of the meat and bones of people who are going to move their sprites around. Let's take a look at COMP2069. We're going to have a bunch of images here that we're going to use, right? So let's take a look at that first. So I'll get out of this stop thing. We're going to look at COMP2069. Here it is. And let's run it. Okay. I'm going to use I can't use my mouse to move it around now. It says, press space to make the cow move. Now you can't hear it because it's inside my ear, but if you actually try it yourself, go on Aptana, and if you press the button, the space button, it goes, ooh. And if you notice, there's a little bit of a movement here on the actual cow itself. It moves its head back, right? It moves its head back up. Right? Let's take a look at that again. Ooh. Right? Ooh. Let's try this again. Make sure we have no issues here. Sorry, I just got to turn Bluetooth off. We're going to have an issue. Then you won't hear me anymore. Hello? Good. Okay, so again, the cow moving, ooh, it moves, and everything is good, right? What we're doing here is we're using a bunch of animation to make that cow move effect work. Let's take a look at the code. Okay, now it also does, it's a multi-frame animation, but it also uses a different state where you have different states for standing and moving. Okay, so let's take a look at this class now. Okay, so we have the cow sprite. Here's the cow sprite. Same kind of sprite class. In the constructor, we're not actually using the constructor to pass new information in there, but we do have two different. And if you notice the standard here, if you will, or the way we kind of define our constants, right, is to use these capital letters. That's our kind of our flavor when we do it in Python, right? So here's standing and moving. There's two different constant class variables that we're using. Standing is equal to 0. Moving is equal to 1. Okay. So we're saying this, self.loadImages, okay, that's the first thing we do, that we're going to call the loadImages function or method. Let's go down here. Here's our loadImages method. All right, well, how do we do this? We say self.imageStand, okay, image standing, the standing image is equal to this image here, this bitmap, stopped0002.bmp, okay? And then what we're saying is, I'm converting it to a type of image that Pygame understands in Python. I'm creating a transparent color. My transparent color, it says, starts at 1,1. So the actual image itself for the cow, whatever that color is, that's going to be my transparent color. And I'm using the set color key to set my transparent color to whatever that one is. Okay, that's the first thing. Then I have a list or an array of images, of moving images. And I'm going to load that a bunch of moving images from my hard drive, right? And they're going to all be called move E000, and I'm going to sub in here whatever the range is from. It's going to start off at 1 or 0, and it's going to keep on loading different images up into my image name, and it's going to assign my temp image, this other variable. I'm going to convert the image into something that's acceptable for Python and Pygame, and then I'm going to load it into my movimages array, right? So self.movimages.append, I'm going to actually take this new image I've loaded in from the hard drive and throw it into my array. So I'm going to have a bunch of images in my array. I'm building my cow animation array right here, okay? Once I've built my cow animation array, so this is the actual thing that does that. So these are all the images that I'm loading from the hard drive. There's only 10 of them, right? going back to my, I'm releasing control back into my class here. So I've got all the images. Here they are. And then I'm saying, well, self.image is equal to self.imageStand. All right? Self.imageStand. I don't have a self.imageStand here. I got it from here. I've actually defined it here, right? This is where I first defined stand. I've loaded it in. This is the first time I loaded in from the hard drive, right? So it's a standing cow image where it doesn't move, it just stands. So when I don't press my space bar, that is the default image, my standing cow image, okay? That's the first quote-unquote state, the standing state, okay? And then I say, well, look, I want to define my rect region around my sprite. I'm going to define my center as 320 by 240, the middle of my screen. And now here I start the counting, okay? I set up a frame. My first frame is 0, so the first frame, or the 0th frame. I'm setting up a delay of 3. I'm calling my variable delay, and I'm setting it to a value of 3. We're going to see how this works. My pause is set at 0, another variable. And then I'm saying this. My state right now is self.standing. So that is my current state. My self.standing state is 0. That's what this constant is, saying my self state is 0. I'm going to initialize my mixer in here. And I'm also going to load up my sound. So here's my sound itself, right? My moo.og sound. Okay? Now here's where all the work happens, in my update. Here's where I start checking. If the state that I'm at right now is already standing, right? Well, then guess what? My image should be the standing image. That's what this says. Okay, image.stand, or .imageStand, right? Else, that means I'm not standing, I'm moving, right? Self.pause plus equals to 1. So my pause is equal now, it goes from 0 to 1, right? If my pause is greater than the delay, well, in the beginning it wouldn't be. My delay is 3, right? So I'm pausing still, so I skip all this, right? I go back up to here, and I don't do anything. I'm still just moving, right? That's all I'm doing, because once I've clicked this, I say self.pause plus equals to 1, and my pause is not greater than my delay. I'm not delaying anything when I press the button, right? But when it's greater than 3, when my pause is greater than my delay, so when it becomes 4 as an example, I set my pause back to 0, so on the 4th frame. My self.frame is plus equal to 1, so now I'm going to my frame number 2. So here's my frame goes from 0 to 2, right? And then if the frame is greater than the length of the moving images, greater than or equal to the moving images, set my frame back down to 0, right? If it's greater. If not, my self image, my new image, is going to be my moving images and whatever my frame is. Okay, that's what it's going to be. So in other words, if I'm moving, I know I'm moving, right? I'm going to keep increasing the frame, and I'm going to keep loading, changing the image that I have from, I'm going to get the image from my array of images, right? And as the time ticks, and I'm actually changing my my image, my moving, right? I'm going to change it with a delay of 3. So every 3rd frame, I'm going to change the image of my cow. So it's not going to be too quick. That's what I'm doing here, right? So if you run through this again, let's run through it. So again, we start off at 0 for the 0th frame. We kind of come out here and say, well, if we're standing, well, I'm standing, right? If I press my spacebar button, which happens down here in my my event, my game loop, right? I'm not only listening for my quit, but I'm also listening for my spacebar here. So here's K-space. Then I'm saying my cow state is moving, right? And I'm playing my sound. So not only is my cow moving, I'm playing my sound, and now I'm going to create that update, right? I've changed, here it is, where I've changed, and I showed you this in the last example where I used the constructor method to create an object, right, that was customizable. But here I'm actually using the property. I'm actually accessing the property with my dot accessor, right? I'm accessing the state of my cow, and I'm changing it to cow mooing, which is our standard, our constant, which it's a 1, right? And then I'm playing the sound. But the reason why I'm creating the delay is so my sound matches my animation. That's why this delay is in place. So now I'm moving. Okay, I start off with a frame of 0 as an example. And again, if I'm going to check this out again one more time, so this doesn't apply. This check is passed because I'm not standing. I'm moving. So the else is in effect. Now I say, if self.pause plus equals to 1, so now my pause is a 1, and my delay is still a 3. If my pause is greater than my delay, that's not true. So this whole statement is passed. It's passed over in my update. I go back. So my frame is now, my pause is now 2, right? If my pause is greater than my delay, second frame, I paused, right? Come back over here, because this obviously this passes all over this, right? Third frame, is my pause greater than my delay? No, they're equal. Okay, keep going. Now my fourth frame, it is greater. My pause is now 4, my delay is 3. I set my pause to 0, right? And now my frame is plus equals to 1. So instead of, it goes from 0, which is my standing frame, to 1, which is where I'm starting to move, right? And then I say if my frame is greater than the length of the move images, right? I only have 10 of these move images. If I'm greater than that, well then set my frame back to 0, reset my state to standing, and change the image that I'm going to show to the standing image. Otherwise, if it's not greater than the length of my images that I've loaded up, assign the new image to the image referenced by the frame that I'm at. So frame 1, frame 2, frame 3. So it's basically a 3 or 4 frame delay before I start moving my cow. So the moving starts, and then I start my animation. Okay? That's what this thing does. It's a little bit tricky, but with animation, you have to kind of, and whenever you match your animation to your sound, that's the tricky part. Otherwise, you're going to have the cow move, and it hasn't moved its head, so it doesn't give it the proper feedback to the user, giving that effect or the illusion of animation. Okay. So lots of stuff here. So here's and he got this thing from Reiner's tile sets, right, as an example. And there's a lot of tile sets out there, but this is where he got the cow images. And I'm not sure if this link is still good. It's been a while since we've checked it. Let's just check it now, right? And I'll use Google Chrome for this one, just to be different. As I thought. Unfortunately, what ends up happening is over time, guys, that a lot of these these websites change their links around, and they're not required to let you know where anything is. So this is the new website, as an example. Oops, we don't want that. See what happens when you go to these websites? I know. It's all these German websites, these bad guys. But if I was to look at this Reiner's tile set, this is where your Google Foo would work, right? This is where the original author got the images. And again, I'm going to go back to Chrome for a second. I had to close that off, just because your sensitive eyes can't see that kind of stuff. You know how it is. And if you look at Reiner's tile sets, and it says 2D humans, this is what you would probably want to do, right? There's 2D humans, environment, graphics, all this kind of stuff. There's some really cool things here. So let's look at 2D monsters, right? So here's an example of some monsters. And if I click this, and it's hard to see here, but there's different kinds of monsters here. If I download this ogre, as an example, right? Look what it says here. It has stopped, walking, running, attack. It's been hit, tripping over, looking, and talking. These are all the different states of this sprite. Okay, that you can download for free here, right? So let's just download this thing and take a look at this image. I'm just using an ogre as an example, right? So here's my ogre sprite. Okay, and here's the ogre, and here's the images, right? There's a bunch of images here, right? They're all Photoshop compatible bitmap files. Let me just take a look at the first one, right? You have to bear with me as my Photoshop opens up. Now you don't have to open it with Photoshop. You can open it with you can open with other images. So that's a bitmap file, right? You can open it with Paint, whatever, right? Photoshop is just my default editor for bitmaps, right? So there it is. So if you look at this image, and I'm going to zoom in here, that's the image of the ogre. That's the standing image of the ogre, the first image, right? So it's got a couple things here that we have. We have a shadow. We have this background color, right, for the ogre, and this is what you want to make your alpha transparency. You want to set this as your color key, right, to make this transparent color. So anywhere where you see this image, it's going to look transparent when you're actually setting up your sprite. So again, going back, I'm going to go back to my Chrome here. So there's a bunch of things. I've got 2D monsters. Yeah, they all look different. Different angles. Look, this one's got a different angle here, right? There's different states, and it says stopped, walking, attack, been hit, tripping over, book reading, right? Sleeping, start, land, floating, and flying, right? So there's a bunch of images here that you can download here at Reiner's tile sets without having those other odd graphics. There's humans. Here's some humans, right? Queen, Luigi, right? Arno, different people that they've named here, different humans, hunters, and so on. The 2D environment, so you've got, this is kind of neat, you've got some tiles you can use. Trees, a square hill, stones, and all that. So you can actually build your tile set right from here. If you use this, and I recommend that you take a look at it for those of you who want to challenge yourselves out in the corner over there. Things like Tiled. Okay, there's an actual free application you can download called Tiled, and I'll take a look at that later on. You can actually build your tile sets, right? These are all tile sets that you can use, and this is a Ripple Earth Light as an example, and it says this is the tile set. It's 1024 by 1024 tile set, okay, of Ripple Earth Light. So you can create your environments over here as well without having to look for it. Let's take a look at animals, right? So here's animals. And over here, there's a bunch of different things here. There's, there's planes, there's graphics, right? Buildings. Here's buildings, right? He's got a lot of little things here that you can add in here. And there's also some 3D stuff, but we don't really care about 3D so much. Okay, but there's some really cool things here as well. Like they have tile cutters. They have different things that allow you to do different things for your, almost like a freeware archive of different tile sets that you can use for your animation. Okay? Not just the cow. The cow is just the one we're using here for the class, but this is where we get it. And this is obviously wrong. It's not Reiner's tilesets.4players.de. It's just Reiner's tileset.de. Okay. So here's the images. We want to do a couple things. We can either draw, if you're an artist, right, and you're a good animator as it is, or whatever. If you want to be an animator, you can draw each of the image states. So, for example, you might want to draw, if you're an artist, you start off with a standing state, and then what you want to do is, if the person is moving, you want to draw every state that he's moving, or her, or the creature's moving, and it takes a lot of effort, and there's a lot of training involved there, right? Or, if you're like me, and I'm not an artist, and probably a lot of you aren't an artists, you can download a lot of these freeware images that exist that you can use for your own games, or modify the ones that exist out there with little effort. Then, second thing is you place the images in the program folder, or a subfolder, right? And then name the images sequentially. This is the one way you can do it. There's another way after that. We're going to explore a different way as well. In this particular case, we call them move 01, move 02, and so on. And then what you want to do is you want to loop through the images. You want to load them all up inside an array, right? And there's another thing it says, modify the images in an editor, right? In my case, I'm using Fireworks, to trim the excess blank space and transparency, or rotate them, or do whatever you need them to do. Okay, so this is the way you can prepare your images. Okay, let's build the cow sprite. So let's look at cowmovefast.py. So that's kind of a neat little thing, that Reiner's tile sets. I like that. here's cow move fast. And what does it do here? If I run the code, if you notice, there's no moving, right? It's just, all it's doing is it's moving its head up and down, right? Over and over and over again, right? How is it doing that? Again, I'm loading up my 10 images. Here's where I'm loading my 10 images, just like the last time, right? Except this time, if you notice, I don't have a space bar. I don't care about the space bar. It's going on its own. So as soon as my cow is instantiated, I put it part of my group, and then I hit my update. So now, on my update, here's my load images. That's not different. It's my update class that's changing. Now, there's no actual moving going on here, right? All I'm doing here is I'm saying my frame is plus equal to 1, and if my frame is greater than or equal to the cow images, set my frame to the standing frame, which is the 0th frame, right? Otherwise, I'll load up my images inside of my my moo images array. That's all I'm doing. So all I'm doing here is cycling through all my images. This is a good example. In this particular code, cow move fast, it actually loads up all the images and repeats it over and over again. The standing state to the moving head state over and over again. Okay, that's all this thing does. Oops. Okay. Okay, so we talked about this and this. So again, image stand is the default image, loaded in the normal way, right? It's the first image where the cow start it kind of sits in place, and then from there it moves its head. Okay. And we kind of talked about this temporary image that it's going and delaying the animation. We talked about how we delay the animation because at 30 frames per second, it'll move at 3 times per second, right? Which is way too fast. Moo, 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 moo. It's too fast than it would be for a regular cow. Cow goes moo, right? For those people who are sleeping out there. All right. Moo. There we go. You like that? I have no problem doing that kind of stuff. Listen, in this industry, you've got to be a good actor, okay? If you're not a good actor, you can't be a good animator or an artist. That's what my friend Roy tells me. All right. So cow moo delay.py is the next one. Let's take a look at that one. I keep doing that. Cow moo delay. I like how you challenge me. Okay. I don't mind it. Cow moo delay is very similar to cow moo, except this time it's created that delay in animation. Ooh. And now the mooing is much slower, if you notice. And it's going to keep doing it on its own. Every 6 frames. Right? So here's a delay, 6 frames. As an example, it's got it loads up the sounds like it did before, and then what it does is it loads the cow images at the same time. And all I'm doing is using my pause and my frame count to basically once it goes to 6 frames, the moo sound starts, and then it waits 6 frames for my cow head to move. All right, so it's kind of a slower moving image. Okay? But very similar to the rest of the stuff. All this stuff here, again, my load images hasn't really changed. It's exactly the same as it was before. And this hasn't changed here. The core of my code is exactly the same. It's my update that's changing. And it says basically, if my pause, self-pause plus 1, so I'm moving to the next frame, if my pause is greater than or equal to my delay, which it isn't, right, then load my animation, right? So it's waiting 6 frames for me to start playing my sound and so on, okay? So because if it does it over and over again, right, then it'll be one moo after the other. Moo, 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 every frame. We don't want that to happen. We want the moos to finish, which takes about 6 frames, and then the moos to start again, right? So that's why that 6-frame delay. Okay. So the only thing that changes again is the update. So again, the animation frame is advanced, which is neat on when those two things are equal. When self.pause is equal to self.delay, the animation frame is advanced, and then eventually it's set back to the original or the standing cow image. Okay. We talked about this before. Why not just lower the frame rate? Right? That's not cool because if all it's going to do is lower everything. It's going to make that sound. It's going to slow everything down, including the moo sound. It'll go moo. You like that one? Moo, really slow. And that's not good either because that's not a realistic sound. You don't want the sounds for your game to be slowed down as well. That's why we don't play with frame rate, right? And that's another reason why I'm suggesting to you don't touch frame rate, because your frame rate, if you fool around with frame rate and you have a background sound and then you change the frame rate, all of a sudden the sound starts getting quicker, right, and shorter. So it might pitch it a little differently than it would if it's the regular sound. So that's why you don't play with frame rates throughout your game. I don't recommend that. Okay, so a multi-state sprite, what is that? We want to use the cow moo example again, and again the default state is standing, right? But we also want to have the ability for us to, when we move in a specific direction, like a walking, when we start walking around, I've kind of hit this all with your standing and moving and all that, responding to the space bar. We've kind of covered all this. We want to modify this so when it moves in a specific direction, right, the cow actually starts its walk cycle. Okay, so we're going to talk about that in a second. Okay, so we're not going to look at the update method. So here's part two. So we had the first time what we were looking at is a bunch of files. We have like 10 files for the cow image. But why not just use one file for the cow image and make us look at different parts of the file? For example, a sprite sheet we talked about before, right? So sometimes we want to do that with when there's a lot of images, right? We don't want to load up different files because it takes up a lot more memory and a lot more time. We just want to load up one big file. Let's take a look how that works. Let's take a look at chopper.py. This is kind of neat. Oops. Here's chopper.py. And let's see how this works. So I'm loading up. Oh, there's the chopper. I can't move the chopper. I can't do anything with it right now. But if you notice, it looks like it's being animated, right? The actual the chopper blade on the top and the chopper control blade on the back they're both working, right? Or it looks like they're moving. So how do they do that? Let's take a look at the code. So here's our class, chopper. All right, we're not passing anything into the constructor this time. We're creating that 3-frame delay, right, for the chopper itself this time again. We're also basically saying this, self.image is self.imageList0, right? So I'm saying there's an image list. And we're doing that within the constructor, but we haven't really referenced an image list yet. So let's see if there's an image list that we've kind of defined somewhere down here. Well, we haven't done that, right? So where is it getting that image list in the first place? I mean, we're creating our images. Well, we're getting it from this, self.loadImages, right? If you look at the load images method, right? Here's load images method, right? It says image master is equal to heli.bmp, right? We're going to convert it. Then we create this thing called image list, and it's an empty array. And now I'm setting up my image sizes. All of my image sizes for my choppers are 128 by 64. Okay? And then I have an offset, 2 and 78, 134 and 78, 266 and 78, 398 and 78. These are our offsets. And what I'm doing is I'm saying, look, split the images on the screen. That's what I'm going to be doing, right? Set up the image list by taking a look at the offset and increasing it. Here's my tuples, right? I'm going to keep changing my tuples as I cycle through the list. That's what I'm doing. Well, let's take a look. I mean, it's kind of hard to visualize what I'm doing here. So let's take a look at the original tile set that I'm looking at. So I'm going to cancel this out for now. I'm going to kill the plain image. And this time I'm going to load up. We're going to go to less than 8. All right, so here's all my cow images, right? And this time, eating, sleeping. I think it's called Chopper. Maybe not. Or Heli. Yeah, I passed it. There it is. So here's my heli, right? Do you see what's happening here? Take a look, guys. So in here, I've got these images. I got one, the second image with a shorter blade on the top here, and this blade here, this back blade, this control blade is moving to the diagonal. Then the blade becomes larger again, right? This blade here in the back goes to horizontal, right? And then this blade goes smaller again. This blade goes diagonal the other way, and then it's back to the standing image. So there's 1, 2, 3, 4 image states. Okay, and if you look at the size of the image that I'm looking at, right, it's saying my image size is 128 by 64. So let's create a box 128 by 64 that I can move around. So 128. I'm just going to create the box here. Height 64. I'm going to add in a border to the box. Oops, that's not what I wanted. I'm going to make the, I'm going to add a border of 1. Okay, so this is the size of my bounding box right here, right? Oops, nice. Try that again. So that's really the size of my image. That's the image that I'm looking at, 164, right, or 128 by 64. Now, if you notice, 128 by 64 barely covers my sprite. I don't know why this author decided to do that, right? Let's take a look here. If I go all the way, if I scroll over on the other side, here's the next one. So here's my actual sprite itself. Oops. I'm just move the big sheet here so you can see it. If I try and stay in the bounds of my box, almost perfect, 128, right? But as you can see, they're all the same. They're all the same shape. Pretty much 128 by 64 is each of my sprites. How do I get this offset? What are they talking about when they talk about offset, right? So here's my little bounding box that I look at, right? It says my offset is 2 and 78. So 2x, 78y. Why did I do that? Well, because if you look at where this is, if I pull down a little a guide, right? If you notice, the top of my box here, right, is 78. This is my 78, right? And here's 2 for my guide. So I'm starting to look at my offsets here. So I'm always going to look 78 down. Can you guys picture a different way to do this? Why would I create a sprite image sheet that has 78, an offset of 78? I got to keep looking 78 down. Is there an advantage to doing that? The answer is no. It's better to create my sprite sheet so that the image is a little bit higher. Right? I don't want to have an offset of 78. There's a lot of wasted space here, right? And I never really use this one. I don't go to this one ever. This image here, I'm never touching this image. I'm only going from this one to this one and to this one. And all I'm doing is increasing 64 or 128 every time, right? So my offset originally is 2 and 78. So it's 2 and 78. My image size is 124 and 64. And then what I'm doing is I'm saying, well, my next offset is 134, so 128, right? It's more than plus 2. There's going to be some separation, obviously, between my next image and the first image. There's only 4 images, 1, 2, 3, and 4. And all I'm doing is cycling between these images. So I'm actually looking at one sprite sheet using an offset value, and I'm looking at the next image and the next image and the next image along that sprite sheet. Okay. So here's where he got it from. He got it from RE SpriteLib. Let's take a look at that. That's another little resource that you can go to for the Heli bitmap. Now, let's see if RE SpriteLib actually exists, because you know how we did this last time, right? So I'm going to use Google to find RE SpriteLib, right? Not really. Well, let's take a look at this one. Maybe it's called Widget Rock Works. Here we go. And this is where you got this big sprite sheet here, right? It includes the original sprite sheet that we used for our 1945 game, right? But again, this isn't exactly what we want, right? So I'm not sure where you got the image for the heli, because that sprite lib doesn't, and the other ones are kind of Ari Feldman sprites. Here we go. How about this one? And he's got a couple of them here. So again, my recommendation to you is you can find other sprite sheets just by simply going like this. If I want to have a sprite sheet, and I want to use a different sprite sheet, and let's say I want to use this one. So here's a different sprite sheet. The guy that's moving, right? It's got different states of his animation here. Now the offset is going to be different for this sprite sheet, this Japanese ninja sprite sheet, than it would be for the other one that we had. We got to figure out what the size of the images are, all the images, the widest image, as well as the thinnest image, and we got to make sure that each of these images are offset equally. And it looks to me like they're not. Okay? So if we were actually going to open this image up, so let's say copy this image, right? And if I open it back up in Fireworks, here's my ninjas. Let's just zoom out a little bit. Okay? And if I was to measure this thing with a box, so let's go to my widest ninja, which looks like this one here. Now I'll zoom in. This one looks like the widest guy, right? Here's the ninja. And if I look here and I draw a box around him, so this are the widest level of our ninja here, right? It looks like the box is 181 by 192, right? Let's just make this transparent, this box. So we'll take away the, and we'll put a bound of, instead of making it black, we'll make it white in this case, right? So here it is. And if you look at it, is this big enough to cover the other guys? I don't know. Right? It looks like this one's pretty wide. Looks like it works for that one, but it doesn't work for this one. Take a look. If I make it this wide for this one, right? Here's our ninja. Let's make this a little bit bigger, so make it 3, right? If you notice, it crosses over his arm. So guys, you might have this issue where the first offset is going to be a different size than the other ones. Right? When you download a sprite sheet. So you're going to get some weird ass effects, right? Because this one, if you look at this, the widest ninja here, is a different offset, right? So how do we take care of that? How do we load it up so we only load up the ninja that we want and that his the body is really centered, right, with what we're loading, right? That's a problem, right? To make it look realistic. Like you don't want your ninja shifting too much all at once or else you're going to have, there's a lot of states here, right? But you've got to have almost like a left bounding box for your ninja. And my recommendation to you is you find the standing image where the ninja is not really moving. And this would be the one right here. Right? So he stands here. Right? And then what you do is from here, these look to be all the same size, these standing images. Right? And then as you move, if you're doing one of these cycles, this one is looks like to be some kind of sword strike. You follow the offsets for this cycle first, so each of the offsets are going to be different. Then you're back to this standing state, right? This one he's doing, he's actually changing another different shape. Let me see if he's actually walking here. He's actually walking, right? He's walking here, so he walked a little bit to here, and then he's changing position, right? So each of these states, you got to figure out what my ninja is really doing. And if you were actually follow each of these positions, one state or another, the offsets are going to change, and you got to create an algorithm to read this sprite sheet. This isn't a great example of a good sprite sheet, though, right? Let's see if there's one that's more of a sprite sheet that's evenly spread out. Here, this is a good example of a sprite sheet. I just want to try and find one that's more interesting, though, where the images are a little bit more stable. Here's the one. Okay, this is more like it. Okay, so this is a walking animation or running. Okay. So again, I'm going to copy this one as well. And we'll zoom out. And we'll fit the canvas. Right? Here it is. So it starts here. And if we build our offset to this one, I think I'm just using the top corner here, and the bottom of his feet to the side of his leg here. Okay, and we're going to just use this one as the background. Let's see if it can encompass, this thing will encompass all of our men. Okay, that works, right? It's going to be a bit of an offset between the two images, but it looks like that's going to work. Works, it's not too big, right? Right? Looks like he'll fit with all these images. So this is a really good, this is a good one. Oh, might be a little bit too small. It might be, this image might have to be a little bigger. And again, you have to look for the widest image. Like it might be a little bigger than 222 by 290. Maybe it's going to be 225 or 223, right? To make it a little bit larger. And what you want to do is try to say, these are all of my offsets. This is how you find the offsets for all the images, right? So that they all fit in. And then what you do is you just cycle through them. It goes to the fifth one. And every 1, 2, 3, 4, 5, 6 images, as an example, for the run cycle, you can shift to the next one, right? Because this run cycle has a bunch of different images, right? It has different layers. So we have 1, 2, 3, 4, 5, 6, and times 1, 2, 3, 4, 5. So 30 different images for this run cycle. And if you notice, this state here, the bottom state, and this state here are identical, right? Or pretty much so. Maybe slightly different. Right? So what you're doing is you're cycling from this one all the way down to this one, okay, as he's running. So I just wanted to show you different kinds of images there. Okay. So again, examine the size and position of each subsprite, and I think that's what we were doing, and then you create a chart. In this particular case, what he did is, he said this. He says image 0 is left is 2, top is 78, width is 128, height is 64. So you create this little, this chart, and then when you create the images and everything else for in your code, you have this chart of all the images. In this particular case, the running man sprite we just saw would have 30 lines, so 30 different images. So quite a few images for him, and it looks pretty smooth. So at 30 frames per second, and if we were update to the image every second, you'd have 30 smooth frames of him moving. It would update every second. It would look like a very smooth animation. Okay? But we'd have to create the offsets, and I don't know the offsets for that running man sprite now. But we can try it. It's not an issue. Okay. So here's another thing. It says extracting a subsurface. And we use a variant of the blit or display function. So we say surface A, and then here's this new thing we're learning. We're saying position, whatever the position is, and the offset and the size, right? So surface A is the surface you're copying from. Surface B is the surface you're copying to, because you're taking the sprite image from the sprite sheet. This is how you do it here, and you copy it from one surface and you paste it, a small subset of the sprite, into your second surface, right? The position is where you want to copy on surface B. So you say, well, what's my position going to be? And obviously, to me, unless you want to fully do an image copy, you just want to do it in the same place, from surface A, surface B, right? And then what you want to say is what my upper left corner of the image you want to extract from surface A, and then the size of the image in terms of how big it's going to be extracted. So 64 by, and it's a tuple usually. So that's that line of code right here, right? So we're saying we're going from our image master to our temporary image, right? That's where we're copying from. So we're taking it from our sprite sheet, putting it into our temporary image variable, right? And we're going to set it in the 0, 0, the top left corner position. Our offset is going to be the first offset, 278 in this particular case. And our image size is going to be a tuple, 128 by 64. That's how big it's going to be. So it's going to offset, it's going to move down, and to the, or down and to the right, as it's going to, so right 2 pixels, down 78 pixels, and then that's where the offset's going to start, and then it's going to read an image from 128 wide by 64 high. Okay? Again, we did the same thing as we did with the cow. We created an empty list, and we appended each of the new objects into the list. We set the color key to the background image of the the chopper, in this particular case, so that you wouldn't see it anymore. Okay. This is cool. And excuse me, people watching the movie. Sometimes you do want the sprite to be facing a different direction. We can use the rotate function on the actual image itself, right? Instead of actually rotating the sprite. So you can explore that. We're going to cover that in the next, in our next section. So next week we're going to cover image rotation in detail. But that's how you do it. You can transform the sprite by using a rotation transformation. There's advantages and disadvantages about doing this, and I'll discuss those with you as well. The advantage is you're going to get an image that looks similar to what you originally had. You only have to have one image to load in, as opposed to a bunch of different ones. The disadvantage is that the image is going to still be in a rectangle, right? And the rectangle is going to grow when you go into a diagonal, right? And we're going to see what I mean by that over the next movie. So for now, here's your challenge for the next half an hour, right? And I'm going to stop recording in a second. I want you to see if you can load up a sprite sheet like this Running Man sprite sheet that we just saw, and use that Running Man spreadsheet. I'll do it along with you as you do it, or some other sprite sheet instead of the helicopter sprite sheet that we saw before. Okay, I don't need the image to move across the screen or anything or whatever, but I want you to take another sprite sheet for the internet that's evenly spaced, so make it easy for yourself, and figure out the offset and load that image, those sets of images into your screen instead. Okay? So you have about 20 minutes or 25 minutes to do that. Okay?